And hello. Today we're going to look at the electrolysis of aluminium oxide. Um, and aluminium oxide has this formula here. So we have Al2O3. Now, what we're looking at this for is aluminium is too reactive to be extracted with carbon. Okay, we've used that before with copper oxide, but in this case aluminium is too reactive, so we have to use electrolysis. And just so that we're completely fully aware, aluminium oxide has aluminium 3 plus ions and oxygen 2 minus ions in it. Aluminium is 3 plus because it lost 3 electrons when it became an ion, and to become the metal again, it needs to gain 3 electrons. Oxygen, on the other hand, gained 2 electrons when it became an ion, and it needs to get rid of those to become the oxygen atom once again. So what we can do then is we can put our aluminium oxide in a electrolysis circuit, and then your computer can give you a really interesting message. Now, what we do is we can help the aluminium gain 3 electrons, and we can help the oxygen lose 2 electrons. So when we put this in the circuit and then we turn on the battery, the electrons go from one electrode all the way around the circuit to the other electrode. Now, obviously there are more than these 2 electrons here, it's just I can't fit them all on. So that's what happens. So that's fine. But because the electrons have moved from this electrode all the way around the circuit to this electrode, we've now got more electrons on this side. Now, what that means is on this side, we've got more electrons, which means we've got higher electron density, and we might say that this is the negative electrode. Here, the electrons are moving away from it, so this would be the positive electrode. What that means, then, is that my oxygen, with its 2 extra electrons, moves, or is at least attracted to, the positive electrode. Okay. And then it gives up its electrons here. So the electrode continues to suck the electrons away, and these it gives it up, and then it whizzes around the circuit. All the way to the other side. I hope we're happy with that. We've now got a negative electrode here again, and that means that my positive aluminium has got these 3 holes that it wants to fill, and it's positive, so it wants to fill them, and it picks them up. So these 3 fill the holes in aluminium. And what we might see is oxygen gas being given off here, and here we might see the aluminium metal being formed as a negative electrode. So what I've done is I've separated out the oxygen and the aluminium from its ore in an electrolysis cell. So essentially then, to sum up, we have a positive electrode, and my negative oxygen moves towards the positive electrode, and the negative charges are removed from the oxygen. Okay. they then whiz all the way around the circuit, where they are picked up by the aluminium. But we need to take a closer look at each electrode in turn. So first of all, we're going to look at the negative electrode. Now, at the negative electrode, we've got the negative electrode here. We know that charges are going to be added. So if I look at my formula here, I've got Al3+, and I'm going to add 3 electrons to it, and I'm going to make aluminium metal. At the positive electrode, it is a slightly more complicated story, because we've got our positive electrode, and we're going to remove our negative charges. So here, I'm sure we're fairly happy here, we've got 2 electrons being removed, okay? And I'm forming my oxygen atom. However, oxygen doesn't exist as its own on itself. It's a little bit unhappy. So 2 of them then join up, and we get a happy oxygen molecule. But we can also then have a look at a picture like this, and quite often they like using these in exams. So we might have something, these are really annoying. We might then have our cell, which looks like this. Okay. Now our positive electrodes are these here. Okay. So we've got lots of positive electrodes hanging down into our molten aluminium oxide. We then get our negative electrode, which is all of this lining. Okay. So you've got negative all the way around here. So we then got our molten aluminium oxide, and our aluminium is attracted to the negative electrode. Our oxygen is attracted to the positive electrode. So here we are going to form O2 gas released. And then here we've got our aluminium, and it's sunk down here because it's heavier than the Al2O3 ore. But why? Actually, before I move on, this tap is on the side here, so that we can open the tap and we get our aluminium metal. I'm going to put it as a liquid at this point because it's still molten. But why does the aluminium oxide have to be molten in the first place? Well, what we've got on this slide is we've got the structure of solid aluminium oxide. And what you can see here is we've got lots of the grey molecules are aluminium, and the red balls are oxygen. And you can see here that where they're joining up, this represents this cylinder, this bar between the spheres represents the ionic bond. Okay, and just in this small section on the screen here, you can see that there are lots and lots and lots of bonds between the spheres. And this structure is also known as a lattice. Ionic lattice, giant lattice. ionic, and you can even put a giant ionic lattice, and it is really, really strong. So when we start trying to put electricity through here, the ions can't move, and we have to melt it so that these bonds are broken so that the ions can move and can conduct electricity there. So I hope that you've enjoyed this session, and you have enjoyed seeing my computer come up with some wonderful messages. And we will go through some of this in more detail in class. Okay, bye bye.